Welcome participants to my NPTEL MOOC module on exploring healthcare survey data. We are at the verge of the last week contents and last week lectures. As I already pointed out that healthcare without policy evaluation is incomplete, and in most of the research that is taking place these days are focusing on some forms or the other on evaluation of policies, or some impact evaluations techniques have been discussed. The recent Nobel Prize that are being awarded are on this area, and this is quite interesting, and that is why we have kept it for our module. In the last two lectures, we have tried to discuss about the very basic understanding about experimental design and quasi-experimental design. And in the previous lecture, we discussed about RCTs and its design, though the practical approach we haven't done it because of the paucity of time and the right software. This Stata software which we have been referring is not even supporting. The latest software is going to give you the right direction. However, we'll come up with all those practical handouts as well in this one in our next set of the module where we'll be specifically focusing on its practical applications. At this moment, we are trying to clarify with basic examples. Let us stick to this lecture on DID, that is difference in difference method. As from the word itself, you can guess that the evaluation is emphasizing on the very marginal changes in the model. If the difference in the treatment as compared to difference in the control is observed, and if that is significant, that means there is an impact of the policy. This is what we are going to discuss in 15-20 minutes time. So, let us start explaining about it. First one is here to emphasize on the matching methods are usually implemented after the program has been operating for some time and survey data have been collected. Another powerful form of measuring the impact of program is by using the panel method. Those are collected from a baseline survey before the program as well as after the program of operation of a particular focus. These two surveys should be comparable in the questions, and survey methods used must be administered to both participants as well as the non-participants. Using the panel data, this allows elimination of unobserved variable bias. This provides that it does not change over time. So, the very focus of panel data is to actually emphasize on the variable bias, and those are unobserved. Unobserved variable usually does not change over time. Therefore, the panel data can easily capture in the error term, and the error term is expected to be minimized as per the technique. So, unobserved variable bias through the panel estimation is captured, and DID is taking use of this. This approach that is DID, also known as double difference, because we are taking difference of the difference in both the type of data, and this has been popular over the time, and this is also called one non-experimental design or evaluation. DID is also called quasi-experimental design to evaluate policy or the programs. This is an analytical approach that facilitates causal inferences even when randomization is not feasible. So, like in RCTs we said randomization is must, but this is one of the important aspects, because whenever your randomization is not feasible, though we are saying it has to be very random by assumption, but making randomized with the data is in reality is not feasible. So, in that case DID is most appropriate, okay, and this gives better causal inferences without randomization of the data. This design compares the changes in outcomes over time between a population enrolled in a program, that is in the treatment group, and the population that is not enrolled in the program, as that is the comparison group or called the control group. DID makes the use of longitudinal data from treatment and control groups to obtain an appropriate counterfactual to estimate causal effect. Okay, as I already mentioned, this is useful in the longitudinal data. The observable bias can be also dealt correctly. DID uses the outcome of the control group as a proxy for what would have occurred in the treatment group had there been no treatment. Here we are citing one example. The example is on two aspects, on specifically on healthcare spending in two states, that is on UP and Bihar. Let us take UP as the treatment group and Bihar as the control group, where the new health program to lower the healthcare spending has been discussed. In this estimation, the effect of new health program by comparing how healthcare spending in these two states actually impacted to the people before and after its implementation. The DID model includes a certain exogenous of variable which we will refer to as the treatment, a quantifiable and measurable outcome which is either the direct target of the variation or an indirect proxy, a treatment group which is subjected to the change, whereas a control group is similar in characteristics to the treatment group, but is not subject to the change. We have already discussed earlier as well. Regarding the implementation, DID requires data on outcomes in the treatment group that receives the program and the group that does not, both before as well as after the program. So, in that case we are supposed to calculate the before as well as after effect difference in the outcome for the treatment group. In that case we are saying before after, that means BA in the outcome, and also in the control group, that is we have considered as before after for the DC. DC here we have taken the code as for the control group, okay, for the comparison group. So, calculate before and after difference in the outcome for the comparison group as D to C. Okay. So, in that case the first one is here as the calculating before and after difference in the outcome for the treatment group, and the second one is to calculate the before after difference in the outcome for the comparison group as mentioned here. So, basically in the DID what it takes the difference between this BA before and after, and this is DC before and after in another group. So, in that case if there are any changes observed and if that change is significant, that means our program has certain implications and significant impact can be derived. This is a diagram, a chart that gives pre and post treatment of any program. So, pre and post where the treatment is given. So, there is a change can be noted. Now, you can see the constant difference in outcome if it is there, that means change is throughout the same, where if after especially in the post treatment you can note from 4 onwards post treatment the intervention effect can be also noted. In both the case there are difference in the outcome, you can find out the difference, but again you can also find out from which particular effect point you can have major difference. So, that is basically called intervention effect. Okay. And now we are discussing stable unit treatment value assumption. There are certain assumption on which DID is based. In short it is called SUDV, SUTVA. This stands for stable unit treatment value assumption. In causal inference we usually make the stable unit treatment value assumption. This has again two components. First one is called no interference, and that means units do not interfere with each other. the treatment applied to one unit does not affect the outcome of other unit. So, that means it is part of the SUDV, that is having no interference. And second one is there is only one single version of each treatment label, that is otherwise called potential outcome must be well defined. The potential outcome should also be defined prior to it. Okay, then only you can understand whether it has actually created difference or not. Another assumption is called parallel trend assumption. This requires that in the absence of the treatment, the difference between treatment and control group is constant over time. So, that is why it is called parallel. Okay. So, parallel assumption is very required while comparing the intervention effect. So, it is critical to ensure internal validity of the DID models and is hard to fulfill. Although there is no statistical test for this assumption, visual inspection is useful when you have observations over many time periods. So, if you have so much frequencies points, we can observe and find out whether the trends are parallel between these two time period or two groups, and accordingly we can proceed for the DID. Like here in comparison group and trainees, you can see where the log mean annual earnings are given. Okay, the comparison group. Here you can see that the violation of the parallel trend assumption is made because these two are not in fact parallel. Okay, if they are in parallel, then there would have been any sort of intervention could have been tested. Now, validity of parallel trend assumption is presented here. This compares changes in the outcomes for the treatment and control groups repeatedly before the program is implemented. That is in T3 or T1 or T2 or T1 time 3, time 2 and time 1 period. If the outcome trend moves in parallel before the program began, it likely would have continued moving in tandem in absence of the program. Similarly, another test is required for understanding the parallel trend assumption is called placebo effect. Placebo test that usually considered to be a kind of fake treatment, a kind of a scenario is given with certain false information, like a person at the old age used to take if having certain problem with him or her, he has one attention throughout the family that please take me to the doctor. Now they or give me medicines. So, if you give any sort of fake medicines as well, sometimes that works. Okay. Sometimes those fake medicine also works. So, the parallel trend assumption also go by this placebo test. These kind of tests are called placebo. They are called a kind of pseudo experiment with those patients. The fake treatment group should be a group that was not affected by the group or program. Placebo test that reveals zero impact suppose the equal trend assumptions. So, like if you just simply test by another interjection, the trend should have been diluted, trend should have been disturbed. If it is disturbed, that means it is not working, it is not parallel. So, perform a placebo test using a fake outcome, a placebo test that reveals zero impact suppose the equal trend assumption. This is what we just said. Perform the difference in differences estimation using different comparison groups. Similar estimates of the impact of the program confirms the equal trend assumptions. So, equal trend assumption should have been followed. Now, difference in difference in difference. So, triple D is important, not just double difference. So, difference in difference and its difference has to be counted. This adds a control group to the DID framework to account for unobservables group and time characteristic interaction that might not be captured by a DID. When you have some time component, it is not just a cross sectional and its changes, that might be a third component in the usually in the panel. When time component is there, the third difference could also be taken to understand the differences correctly. So, usually you refer to the panel content or longitudinal data with certain time. It argues DID with another difference for the new control group, hence the name difference in difference is referred or discussed. Here are some of the important commands that is essential in running the DID, difference in difference or difference in difference indifference. So, triple D we are not running at this moment per se, but you may follow the latest software. It has already contained all those details. In the previous softwares you will not find that, you have to give some proxy or other direction. At this moment we are actually simply guiding based on the latest software, starter software that has been published. So, the first command is called DID regress. So, DID based regression. So, DID regress is given for the repeated cross sectional data, that too it is a repeated cross sectional data where we sample different units of observation at different points in time. But in case of panel data, that is though repeated cross sectional and panel where longitudinal content is given, more time period is given. So, in that case you have to use the XTDID regress. Okay. So, XTDID regress is most fitted in case of triple D models, okay, and that control for the unobserved group and the time effect as well. Practical example we are citing here, some results will also show and their interpretation can also be explained. A healthcare provider wants to study effect of a new hospital admissions procedure on patient satisfaction. Okay, so they have collected monthly data on patients before and after the new procedure that was implemented on some of their hospitals, those are available. Okay. In the data, the outcome of interest is obviously patient satisfaction. In short, we are writing as SATIS, okay, as the variable name, whereas the treatment variable is called procedure. Okay. So, the procedure, how procedures have been changed. Here as the command DID regress, first one is your satisfaction variable, that is the outcome variable. Okay. Then procedures is the treatment variable. Then it is referred to other factors like group as the hospitals in the group format, then time component if any is there has to be specified. Okay. The first set of parentheses is used to specify the outcome of the interest followed by the covariates in the model. So, they are other covariates basically. Then in this case there are no specific covariates. The second set of parentheses is used to specify the binary variable that indicates the treated observations, okay, and that is called procedure, and the others are like group or time are used to construct group and time effect that are included in also the model. The variable specified in group is defined as the level of clustering for the default cluster robust standard errors. Basically, group is given to compare which set of hospitals are actually giving much better trends in terms of satisfaction. So, for this example, we cluster at the hospital level only. So, hospital has been considered through the group. And here is some of the sample result that was taken from the latest starter software, and the information given here is comparing with the number of groups and the treatment time. So, the first table that is here gives better information about the control and treatment groups, and that simple description is given. This description provides idea about how many hospitals in each groups are there in control groups and treatment groups, and their maximum and minimum observations frequencies are also mentioned at that particular table. Now, procedure as we already said is a 0 and 1, it's treatment and no treatment. Then if it's no treatment, then of course they are the control group, isn't it? And now The first section tells us that 28 hospitals continue to use the old procedure, okay, and 18 hospitals switch to the new one. The second table that is mentioned here gives the standard error, its p values. This application, this is the result based on the repeated cross sectional data. Number of the observations are 7,368. The average treatment effect on the treatment I.I.T is calculated, and this gives 0.85 at the result with its significance level as 0.00. So here is the 0.85. This suggests that the treatment had a 0.85 point increase in patient satisfaction relative to if they hadn't implemented the new procedure. So, if their new procedures are not adopted, so then in that case it could have been lesser, but since those have adopted, this has created a positive change and it is significant. The parallel trend assumption, as we already mentioned, that if it is we discuss about sati per satisfactory as the variable, we try to check some post estimation to draw trend plots, whether the assumptions were actually correctly followed or not. So, the star trend plots actually gives the right direction to it. So, this gives the blue line is the control variable, whereas the the red the one is the treatment one. This has actually corrected the changes or not, whether it has actually changed the trajectory or not. The visual check of this trajectory can be obtained by plotting the means of the outcome over time for both groups, or by visualizing the results of the linear trends model. In that case, it seems that the parallel trend has not been disturbed. Okay, so parallel trend has been followed in observed means as well as in the linear trend model. It seems almost same. The change are not significant. So therefore, it is following the parallel trend. Now you can see this command can also give you whether you are going to reject the parallel trend assumption or not based on the significance level. The command here is called start PT trend. Prior to the policy implementation, control and treatment hospitals followed a parallel path. We can further evaluate this assumption using a parallel trends test with start P trends. Okay. We do not have sufficient evidence to reject this null hypothesis about the parallel trend. That means this test and the graphical analysis supports the parallel trend assumption, since this is not significantly deviating, okay, not rejecting our null hypothesis. All right. Now, another test that is also important to give you certain idea about the causality through the Granger causality. Basically hypothesis is that there is no effect in anticipation of the treatment. With the expectations, the treatment might change, okay, on the outcome, on the satisfaction level. So that has also been checked through the Granger causality test, that is E-start Granger we have taken. That will clarify further that yes, the parallel trend hypothesis has been followed correctly. Okay, so here the test is all about this is not significant. So we consider that it is not anticipating much difference in the treatment, or there is no effect on the treatment. Here the in anticipation of treatment, the control or the treatment group change their behavior. This is evaluated with the Granger causality test. So, E-stat Granger is going to give you the result. We do not have sufficient evidence to reject the null hypothesis of no behavior change prior to treatment. Together with our previous diagnostics, these results suggest that we should trust the validity of our AT-AT estimate. All right. So, these are all the details we wanted to explain. Further details like its direct state applications and all, we will come up with a detailed module in our revised module of this. At this moment we are trying to clarify the concept and how people are using differently. I have also been emphasized. I hope you have gone through it and you will come up with certain ideas and we will discuss. With this, let me stop here. Thank you.